Alright, let's do these partial fraction practice problems. First one, we have this. So the denominator is already factored. It's got an x, so I'll put a over x. And it has this quadratic factor that doesn't factor, squared, so I'm going to have to put bx plus c over the x squared plus 2, and dx plus e over the x squared plus 2 squared. Repeated factor, you just put there. It's a quadratic factor, so it needs a linear on the numerator. And that's got to be 4 minus x over x squared plus 2 squared, identically equal. So to get a common denominator here, I'm going to need the x squared plus 2 squared, which is going to be x to the 4th plus 4x squared plus 4. That's the x squared plus 2 quantity squared. Now this one that has an x squared plus 2, I'm going to need another x squared plus 2 and an x, so that's going to be x to the 3rd plus 2x. And this one, all I'm going to need is an x to make the common denominator. So this would be multiplied numerator and denominator, and denominator and denominator, but I don't need that. So we're going to go through. We're going to have some x to the 4ths, x to the 3rds, x to the 2nds, x's, and a constant. No x to the 4ths, ax to the 4ths, plus bx to the 4ths, and no other x to 4ths. No x to the 3rds, no x to the 3rds, c x to the 3rds, and no other x to the 3rds. X to the 2nds, none. 4a, 4a x to the 2nds, no. 2b, c x to the 3rds, nope, okay, and d. And x to the 1st, we got minus 1, and x to the 1st, none here. X to the 1st, none there. C times 2, 2c, and x to the 1st, e. And the constant, 4, I got 4a, no constants here, and here, since they're times x, there's no constants there. So without doing any matrices here, I see a has to be 1. I see that if a is 1, b must be negative 1 to make that come out to be 0. It says c is 0, and if c is 0, e has to be negative 1, and if a is 1, we have 4 minus 2, which is 2, plus d is 0, so d must be negative 2. If I put that in matrices, I should get the same answer. So my integral changes to the integral of a, which is 1, over x, plus this one, b is minus 1, so we get minus 1 over, and c is 0, so I just got minus 1 over minus 1x over x squared plus 2. And on this one, I've got this dx is minus 2. Minus 2 times 1 over x squared plus 2 squared minus 2x plus e over this minus 1 integral of 1 over x plus squared plus 2 squared dx. Okay, so now to do this one. This is ln of x. This one, if I let u equal x squared plus 2, du equals 2x dx, and the 2x will go underneath the du and cancel the x, so I'll get minus 1/2. And this would be u down here, so it would be ln u, which is x squared plus 2. I'm doing a lot in my head. Take your time to go completely through the u substitution if you're not getting that. Minus 2, and I'm going to do the same u substitution. So this would be u squared, and I get a 2x that'll cancel the 2 and the 2 out. Well, I'll just leave that. I'm going to get a 1/2, and I'm going to have 1 over u squared du, and the antiderivative, these will be, that'll be minus 1, and this will be u to the minus 2, which integrates to be u to the minus 1 divided by a minus 1, so I get minus a minus, which is plus 1 over u to the minus 1, so, and u was x squared plus 2, so it goes in the denominator because it's to the minus 1, and I got a minus out of it that canceled the minus. So this one is this, this one is this, this one is this, and now the last one. And this one is a trig sub. So I'm going to go down here and do that one separately. So I got an x squared plus 2. So to do that, I'm going to put its addition. So I'm going to put an x here and a square root of 2 there. And this will be the square root of x squared plus 2. And that's a tangent of theta equaling x over square root of 2. So secant squared theta equals 1 over the square root of 2 dx, d theta. And the mess would be the square root of x squared plus 2 over the square root of 2 is hypotenuse over adjacent is secant theta. So my integral, that the last one I'm trying to do here, I've got minus 1 times what I'm going to get from this. And that's going to be the integral, the antiderivative of 1 over that mess, well, that's the square root of the mess inside, is square root of 2 secant theta. And if I square that, I get what x squared plus 2, and then I got to square it again, so it's going to be square root of 2 times square root of 2, which is 2, squared again is 4. Secant theta times secant theta, secant squared, squared again is secant to the 4th theta, and my d theta, my dx changes to square root of 2 secant squared theta d theta. And this secant squared cancels 2 of these and leaves the secant squared in the denominator, which would be, I can pull out the square root of 2 and the 4, square root of 2 over 4, and I get a secant squared in the denominator, which is cosine squared theta in the numerator. And then using my tables, the antiderivative of cosine squared is this. So let's move this up here so we can see it. So I'm going to get, so my x is a theta, so I'm going to get, I have a minus 1 times this, so I got minus, well, I'm going to put the answer in here, so I'm going to call it square root of 2 over 4. Cosine squared becomes theta over 2 plus 1/2 sine theta cosine theta plus c. And so theta is the arctangent of x over the square root of 2, and that'll be over 2, so I get 1/2 arctangent of x over the square root of 2 plus x, this times 1/2, which would be square root of 2 over 8, and I forgot to take this one times the square root of 2 over 4, so this is square root of 2 over 8. Okay, take it times that, and the sine of theta, the sine is x over that square root, and the cosine is the square root of 2 over that square root. And that would just be x squared plus 2 without square roots there, and the square root of 2 times square root of 2 would be 2, so it'd be 1/4 x and a minus 1. So yeah, that could be simplified, but that is an antiderivative right there. And that is not a pretty one. Hopefully I don't make too many of those messy ones here. Otherwise I'm going to be here for a while. So this is a linear and a quadratic factor, so we got a over x plus 3 plus bx plus c over x squared plus 9. And that's got to be 18 over those two things, identically equal. So this one has to be multiplied by x squared plus 9. And this one has to be multiplied by x plus 3. So identically equal, I have x squareds. None equals a plus b, and no others. x's. I have none. Over here, I have none there. And I have 3b plus c. And I have the constant. And I have 18. And I have 9a. And no b's because they have x's, and 3c. I'm going to do matrices on this one. I could probably do it otherwise, but let's just do matrices here just so you can see it. So I'm going to do, let's see, there we go. That'll work. Second matrix, edit A, 3 by 3, 1 enter, 1 enter, 0 enter. 0 enter, 3 enter, 1 enter, 9 enter, 0 enter, 3 enter. Second matrix, edit B, 3 by 1, and it's 0, 0, 18. Second quit, clear, matrix A, inverse, A, inverse, matrix B, enter, and so I get the integral, a 1 over x plus 3 dx plus -1 times x over x squared plus 9 plus 3 over x squared plus 9. Okay? This one is ln, absolute value of x plus 3, minus 1. This one, if I do u sub, equals x squared plus 9, I get du over 2x equals dx. I did 2 steps there to get to that. It's 2x dx divided by the 2x. So the x's will cancel. I'll get a 2 in the denominator, and I'll have 1 over u dx, and the 1 over that would be antiderivative would be ln of x squared plus 9. Really don't need the absolute value because that's always positive, but I'll put it on there. Plus 3 trig sub. So I'm going to do that one up here because I think it's small enough. They're added, so I'm going to put x and not 3, and this would be the x squared plus 9. Tangent of theta is the simplest. It's x over 3. So the derivative secant squared theta d theta equals 1/3 dx. And the mess using the constant is square root of x squared plus 9 over 3 is the secant of theta. And we get this to be the 3 on the outside, which I already have, the integral of 1, the x squared. Let's see, if I put the 3 over here, I have to square it to get no square root on it, so that would be 9 secant squared theta, squaring both sides to get that. And my dx is 3 secant squared theta d theta. Secant squareds cancel, and I get 3 over 9, which is 1/3. And I get just a d theta, and the antiderivative of d theta is theta. and theta was equal to the arctangent of x over 3. Plus c. 3. Now I've got x squared minus 9 as opposed to plus 9. Looks almost the same, but it's a whole lot different. So that denominator, x squared minus 9, factors to x plus 3 and x minus 3. So I get x plus 3 and x plus 3 twice. So I put a over x plus 3 plus b over x plus 3 squared, because it's a repeated factor, and c over x minus 3. Has to be 18 over all that stuff. Identically equal. So I got to multiply this one by an x plus 3 and an x minus 3, which is what we've said before, x squared minus 9. This one has both x plus 3, so it needs an x minus 3. And this has x minus 3, so it needs an x plus 3 times an x plus 3, which is x squared plus 6x plus 9. So I got x squareds. None there. I have a, no b's, and a c. X's. I have none. I have b. Over here I have none. And I have 6c. And constant. I have 18. 9 minus 9a minus 3b and plus 9c. Okay. I think you can, we don't get too much reflection right there. Second matrix, edit A, 1, 0, 1. And then 0, 1, 6. And negative 9, negative 3, 9. And for B, second matrix, edit B, 0, 0, 18, same one, second quit. I'm going to do A inverse B, so I just press enter and I'll have it. So A is 1/2, negative 1/2, so I got negative 1/2 the antiderivative of 1 over x plus 3. B is negative 3, so I got minus 3 integral of 1 over x plus 3 squared dx. And C was 1/2, so plus 1/2 integral of 1 over x minus 3 dx. Got 1/2 ln x plus 3 minus 3. This is squared, so it's not ln. U equals x plus 3 du equals dx. So this is 1 over u squared, or u to the negative 2. Integrating it becomes u to the negative 1, or 1 over u. U to the negative 1 divided by a negative 1. And that's the integral of that. Plus 1/2 ln x minus 3 plus c. this turns into plus 3 in front of that. And there's ways you can simplify that, but that's basically it. Okay, now we need to go to 4. So x squared plus 2 over this mess is identically equal to linear factor. Let's see, what's that factor there? There's a 2 in there. I can factor a 2 out. So it'll be 1/2 times everything I get. I can just pull out a half. And I would have a over x minus 1. And this would be x minus 4. So plus b over x minus 4, and I'll multiply both sides by 2, so that'd be 2x squared plus 4. That's how I'll take care of the half. Multiply both sides by half. Should I do that? I don't think I should do that. I'm going to go plus c over x plus 2. I don't know if I want to do that. I'm going to pull the half out and put it here. Forget the half. Keep this as x squared plus 2. And I know that I'm going to have to take half of whatever my answer is when I get done. So this one needs to have an x minus 4 and an x plus 2. Those multiplied would make x squared minus 4 plus 2 is minus 2x minus 8. This one needs to be that times that, which is x squared minus x plus 2x is plus 1x and minus 2. And this one would be these two multiplied, which is x squared minus 5x plus 4. So, forgetting that half, I just factored it out, put it on the outside of the integral. It's 1x squared equals a x squareds plus b x squareds plus c. X's, none. Minus 2a plus b minus 5c. And the constant is 2. Negative 8a minus 2b plus 4c. Going to the matrices. Second matrix, edit A, 3 by 3, 1, 1, 1, negative 2, 1, negative 5, negative 8, negative 2, 4, and the constants, edit B, 1, 0, 2, A inverse B I just did, so I can just press enter, and I get negative 1/3, 1, and 1/3. So I got negative 1/3 integral of 1 over x minus 1 plus b was 1 over x minus 4, and c was 1/3 of 1 over x plus 2. So I got negative 1/3 ln x minus 1 plus ln of x minus 4 plus 1/3 ln of x minus plus 2 plus c. Now I'm going to do a little bit more with this one, just so you know what you could do with this whole thing. These are ln's added, and so the 1/3 could go up as a power, so I'd have ln of this to the negative 1/3, which means I'd have the cube root of x minus 1 in the denominator. Plus means you multiply by this, and so that would be times x minus 4. And the 1/3 on this would go up and make it the cube root, and it's plus, so it would be times the x plus 2. So that's what that says. It's easier to look at that way, but that's what it is. Okay? Oh, and the 1/2 that I totally forgot. So I'd have to take 1/2 times all of this plus the c. So it'd be minus 1/6 plus 1/2 plus 1/6 on these. So it'd be 1/2, or I could put that up as the square root of all that stuff. Square root of all that. Yuck. Okay. This one, I could pull out the 3 and just take care of the 3 later, but I won't. This one's going to be a over x minus 1, b over x plus 2, and c over x plus 2 squared. And that's going to be 3x minus 9 over that stuff. Identically equal. This one needs to be multiplied by x plus 2 squared, so that's x squared plus 4x plus 4. This one needs to be multiplied by an x plus 2 and an x minus 1, so that's x squared plus x plus 2x minus 1x is plus x, and minus 2. And this one I'd have to multiply by an x minus 1. So I'm going to get, for the x squareds, I'm going to get 0 equals a plus b and no c. For the x's, I'm going to get 3 equals 4a plus b plus c. And for the constant, I'm going to get negative 9 equals 4a minus 2b minus c. I could add these two and the c's would drop out, and then I'd take that answer and combine it with that. But since I got matrices right here, I'll go to second matrix, edit, A, enter, 1 1 0 1 1 1 0 4 1 1 4 negative 2 negative 1, and second matrix, edit, B, enter, 0 3 negative 9, second quit. I did A inverse B, so I press enter, and I got negative 2/3, 2/3, and 5. So with the A there, I'm going to get negative 2/3. It's going to be 1 over x minus 1, which is going to be ln of x minus 1, plus 2/3 ln of x plus 2, plus c over that. That's going to be u sub 5, and it's going to be dx is going to equal du, so it's going to be the integral of 1 over u squared du, which is u to the minus 2. Integrated is minus 1 over u, because this becomes u to the minus 1 divided by minus 1, and u to the minus 1 is 1 over u. So it becomes 5 times 1 over x plus 2 plus c. And 6. We'll do this one, and then I'm going to take a short break, and then I'll come back and do the trig subs. So we got x cubed plus 1. This factors to x squared plus 2 and x squared minus 2. Now, I could write this as x plus the square root of 2 and x minus the square root of 2, and it would probably be easier to do that one this ways. Those are still linear factors, so I would go a over the square ax plus the square root of 2, but that's going to get messy when I try to do these. So let's just do the other. I need to take a break. I'll come back and do this one.